All right, good morning, y'all. My name is Noah Mendez. How are y'all enjoying the summer heat? Yeah, me either. But I think I can deal with it as long as the winters don't get colder than they already do. I'm not really built for the cold either. Um, there are plenty of creatures that are already well adapted for very cold environments. And in addition to that, creatures that are adapted for very dry environments that make me feel kind of parched if I think about it for too long. Um, and interestingly, way down south, further than you're thinking, in the world's largest desert, um, bacterial cultures were isolated from exposed soil in Antarctica. And I know that can sound kind of scary. It sounds kind of like a sci-fi horror movie. And I can understand that. It can scare people to think that there's these little things that exist everywhere. And it seems so unimaginable to some that they might not even believe that that things could live in Antarctic soil. Um, so much, forgot my thing. Anyway, so much so that they don't believe that things live in Antarctic soil. But when bacteria can live in things like acidic lakes with a pH of 2 and even NASA's clean rooms, it makes you wonder, why not? And to answer that question, well, Antarctica is really cold and really dry. The further into Antarctica that you go, the colder that it gets. You don't really see much animal life besides on the coast with a lot of like marine animals. And 98% of Antarctica's of landmass is covered in ice, which is where a lot of that water is trapped. But from the 2% of the exposed soil, bacterial cultures were in fact isolated. And so that leads me to the question of, are they 30, flirty, and thriving? Or did they just happen to hitch a ride to the coldest place on Earth? And so my question for the summer was, are Antarctic soil bacteria uniquely tolerant of cold and dry conditions? And in order to do this, I worked with one bacterial species called Arthrobacter flavus. This is a bacterial species that is very adaptable and it is found in soils globally. So I worked with about 20 different isolates from around the globe and decided to compare in my presentation the bacterial species from Tonga, which is in the Pacific Islands, and as I hope is obvious, one from Alaska. Not Alaska, oh my God, Antarctica. I'm a little nervous, sorry, y'all. Okay. Thank you. Um, and to compare the location for coldness and dryness, you can kind of see the difference here where Tonga is very tropical, it's very wet, it's near the equator, whereas Antarctica, as I was saying, is very cold and very dry. And to replicate these sort of environments, what I did was use these 24 well plates and I mixed agar, which is a gelatin-like substance made from algae that can hold nutrients and water in order for us to grow bacteria on it. And I infused it with a compound called polyethylene glycol, which holds moisture, it retains it. It's often used in things like moisturizers and makeup in order to keep like water out of them, things like that. And by adding that into the agar at different concentrations throughout this well plate, I could replicate different environments from soil right after it rains all the way to drier than the driest deserts. I made 5 of these per isolate and then put the tiniest little bit of bacteria into the middle of each of these wells. Once the wells were inoculated, I then incubated them at these 5 different temperatures and took pictures every other day for about a week. This then gave me pictures that I could put onto my computer and use an image analysis software in order to really zoom into these pictures, outline the bacterial colonies, and that would give me how much they had grown in surface area. And when this data was processed, I could see that there was in fact a difference from the different bacteria that were collected from these very different environments. The bacteria from Tonga, the more tropical area, preferred the warmer temperatures, grew best at these warmer temperatures, whereas the one from Antarctica grew best at a lower temperature. And we had a similar thing go on when we were testing the water potential or the water availability, where the Antarctica sample could grow better even when there was less water in comparison to the one from Tonga, which eventually just dropped down to zero growth when there just wasn't enough water, even at its optimal temperature. And when we put these together onto one graph with water availability on the horizontal axis and temperature on the vertical axis, we saw that where this graphs are brighter is where the most growth was of these bacterial colonies. And it's very clear that the Tonga isolate preferred the very warm and very wet environments in comparison to the Antarctica one, which preferred the colder temperature and could grow at just about every water availability. And what this tells me is that environmental conditions do have an influence on the preferences that soil bacteria have for how much they grow, where they grow. And it's possible that temperature and water potential are linked, because when we tested them for water potential at their growth optimum, they could grow better with less water. And to answer my question, Arthropactor probably only grows in little spurts when the soil in Antarctica gets warm enough or gets a little bit of water. But because we could actually culture them from the soil, that means that they're still alive. They are still having these metabolic processes going on that allows them to come back and then be cultured in the lab. And what this ultimately tells us is that when we study Antarctica, because it's such a unique environment, the NSF actually has a full project dedicated to the study of Antarctica, its location, what makes it unique. And this can lead us to asking questions about what are the limits of life? Where are adaptations shown on DNA and RNA? And then leads us to where else in the universe can we find life? Thank you very much.
Well done. Question? Yes.
So since it's the same species in both locations, did you think about playing around with each one and seeing how long it would take, giving it generation after generation to see how long it would take to swap preferences or anything like that?
That is something that I think is super fascinating. I just didn't have the time to do that this summer, but I think it could be a future direction that this sort of project could really go into. Yeah. Yes, Antarctica, and from my Tonga sample came from a temporary island in Tonga. Yeah.
How did the bacteria get there in the first place?
That is a great question. It's very likely that they traveled through wind, especially further in. My isolate was collected from along the coast, so it very possibly could have washed up. I don't know their tolerance to salinity and the ocean, how they exist in the ocean. So most likely air though. Any other questions? Oh,
Would you say that your study further shows how resilient life is?
I think it does. Along the coast from where my isolate was taken, it still is very, very cold, and despite being near the ocean, it can still be very, very dry because that's salty water. It does snow in Antarctica, but it doesn't rain. That water doesn't actually seep into the soil. So there still is those conditions that these things are still living within and then able to be transported and, like I said, cultured and then in the lab.